When you cross the edge of the universe, strange things happen. Can you see the creator in a 19th century print? In order to find the answer, today, take you out of the universe. What can you see out there? Suppose you are on a spaceship, flooring the gas pedal in one direction away from Earth, until you approach the speed of light, and you have infinite lifespan. What will you see when you cross the boundary of the universe? Will you crash into a wall? Or will you pass through it? If you pass through, where will you end up? This question has puzzled humanity for millennia. A 19th century print shows how people in the Middle Ages imagined the boundaries of the universe. Beyond the boundaries are the mechanisms controlling the universe. But we have yet to arrive at a final answer to this question. Today, we will explore several of the most probable theories, to explore the most apparent yet elusive beyond of the universe. First, let us clarify some key points. When you observe each other, you see what he looked like 3 nanoseconds ago. When we see Betelgeuse in Orion, we see what it looked like 500 years ago. But it might have already exploded. Gravity is the same. The sun you see is what it looked like 8 minutes and 20 seconds ago. And the gravity acting on Earth is also from 8 minutes and 20 seconds ago. If the sun were to suddenly disappear without a trace, Earth and the other planets would continue for a while, orbiting around an empty space, then eventually drift apart in different directions. Also, the Andromeda galaxy is heading towards us at about 400,000 kilometers per hour. In reality, it is nearly 900 light-years closer than we see. Overall, you cannot observe something in real time. The farthest distance we can observe, it is the point that light has reached since the Big Bang. The closest such point to us is over 46 billion light-years away. This 46 billion light-years is the boundary of the observable universe. Are the objects beyond this distance remnants from before the birth of the universe? However, what we are looking for is the true boundary, not just the visible boundary. Regarding the edge of the universe, astronomer David Kipping answers this question in the most detailed way. Your spacecraft starts in the first second, traveling at a speed of 10 meters per second. In the second second, at 20 meters per second. In the third second, at 30 meters per second, and so on. After 35.28 hours, the spacecraft will fly past the Moon. A week later, it passed by Saturn. 11 days later, it will skim past Neptune. This is the farthest planet in our solar system. For this thought experiment, let us ignore practical issues, such as fuel supply and the potential catastrophic collisions with cosmic dust. After 15 months of flight, you have traveled its first light year. At this point, due to the influence of Einstein's theory of relativity, when you accelerate to 299,792,455 meters per second, the last 3 meters per second of speed, even if you exhaust all the energy in the universe, you will only approach the speed of light at 299,792,458 meters per second, but will never reach it. If it weren't for this limitation, the spacecraft would exceed the speed of light in 45 days. But in reality, things will be different. The theory of relativity posits, the faster we move through space, the slower we move through time. Therefore, in this situation, some counterintuitive phenomena will occur. When the spacecraft's speed approaches the limit, external observers will perceive the spacecraft's speed as slowing down, while you on the spacecraft move as if in slow motion. But from your perspective inside the spacecraft, time passes normally, with acceleration still maintained at 10 meters per second. Furthermore, from their viewpoint, time outside the spacecraft seems to have accelerated. Here comes an outrageous fact. On October 15, 1991, a cosmic ray particle known as the God particle reached Earth. It is still unclear what this particle is. However, its name comes from its energy. It is equivalent to the energy of a baseball moving at 93.6 kilometers per hour. Just think, this is only the energy of a single particle. This particle travels at nearly the speed of light. Specifically, it reached 99.9999999, 51% of the speed of light. Scientists have yet to understand what drives this particle. Recent studies conducted using a telescope array project suggest that its source lies in a region 20 degrees in the direction of Ursa Major. The most astonishing thing is that, for this particle, time has slowed down. Just think, compared to a stationary observer, time has slowed down by 300 billion times. This means that while we stationary observers need 2.5 million years to travel from the Andromeda galaxy to here. But this particle would perceive it as less than 5 minutes. This means that time for light itself has completely stopped. This principle is clear. But the difference in the rate of time compared to other parts of the universe is only part of the problem. If you don't return now, but keep flying, then after crossing the threshold of 8.3 billion light-years, you will be unable to return. Although there are no cosmic walls there, once you cross the mark of 8.3 billion light-years, due to the expansion of space, your causal connection with the solar system will be severed. No matter how fast you accelerate, you will no longer be able to return to its vicinity. This is because the area of space you are in is moving away from Earth at a speed greater than light. There is no violation of physical laws here, because we are discussing space itself, rather than the objects within it. The same principle applies to galaxies in the universe. If you fly far enough away from Earth, you will enter a region moving away from Earth at a speed greater than light. Even if you accelerate back to Earth, you will still be moving away at a speed faster than approaching. Don't despair just yet, but this is only part of the story. You will also face even more absurd realities. I discussed this in my previous video. Due to dark energy and the expansion of the universe, our visual range is not limited to 13.8 billion light-years, but extends in one direction to a full 46 billion light-years. And this is just the current situation. As space continues to expand, in the future, this visible sphere will also expand, but only to a certain extent. According to calculations, the scientists estimate that our future observational limit will expand by approximately 33% compared to the current limit, specifically reaching about 61 billion light-years beyond. Although our visible universe can expand, visible does not mean reachable. Dark energy, this powerful yet hard-to-understand force, has actually divided the universe into concentric regions. In regions less than 15 billion light-years away, there are 66 billion galaxies. Theoretically, if you travel at the speed of light, you could reach these galaxies. But you will never see these galaxies as they appear today. They will remain forever in still, gradually fading farewell photos. And galaxies between 46 billion and 61 billion light-years away are currently invisible to us. But our descendants will see them, because their past light will eventually reach us. However, galaxies more than 61 billion light-years away are invisible and unreachable to us or anyone else, even in the farthest future. For example, the GNZ11 galaxy. This is one of the most distant galaxies known to us, with an age of 13.4 billion years, meaning its light was emitted 400 million years after the Big Bang. It is 32 billion light-years away from us. We can still see it, but the light emitted by this galaxy will gradually fade. Ultimately, they will disappear forever. This galaxy is currently moving away from us at 687,000 kilometers per second. More than twice the speed of light. More than 96.7% of the galaxies we can observe today have already disappeared. The light they are currently emitting will never reach us. So, as time goes on, each galaxy will gradually fall into darkness and solitude. The emptier space becomes, the stronger dark energy gets. The universe will be just an empty space filled with dark energy, causing it to expand exponentially. Now is a good time to return to our imagined spaceship. If you continue to travel at speeds approaching the speed of light, when the clock on the ship strikes the 200th year, 10 to the power of 41 years will have passed elsewhere in the universe. That's a number followed by 41 zeros. Due to the expansion of space, at this stage, it is likely that there are no other particles in the observable universe besides the ship itself. The spaceship will forever traverse a pitch-black universe. So is this what it looks like when you cross the edge of the universe? You might think that the first attempt to reach the edge of the universe has failed. The universe may end before we reach any hypothetical edge. But this is just the beginning. We have made these assumptions solely based on the premise that the universe is flat. What if the universe is not flat? What if the universe has higher dimensions? In the next episode, we will unlock a journey to other forms of the universe's boundary.